Parsnip Training Tutorial, Intermediate Language. In this video, we will explore examples of the Parsnip intermediate language. As you will see, we are not using a MySimple protocol. Unfortunately, a simple protocol cannot help us illustrate the full range of the intermediate language's extensions, extents, and capabilities. An intermediate language is a human-friendly language that can be easily translated into computer-friendly code. Let's start out with the configuration file, also known as the config file. The intermediate language's parser configuration is similar to the front end but includes additional fields, some of which will eventually be exposed in the front end while others remain hidden for use by advanced users. Here, we are using HeartIP for the protocol. This protocol can be run over either TCP and UDP protocols. It runs over TCP/IP rather than Ethernet. In more common terms, this is not a Layer 2 protocol. There are two generated files that need to be user-defined in the protocol configuration file: the conversion file and the signature file. The conversion file is a base64 encoding of the functions used for user-defined types. The signature file is a base64 encoding of a DPD signature. This is an advanced feature, and we won't cover it today, but I wanted to show you that it exists here. If you're interested, you can read more about DPD signatures in the Zeek documentation. Here you will also see custom field types, this for adding unique interpretation of the data that are not common enough to be supported in Spicy by default. For example, in HeartIP, the date is formatted differently from the way we expected it to be formatted in Spicy or Zeek. To handle the date formatting difference in HeartIP, follow these steps. Create a date conversion function in C++. Parsnip will automatically pass bytes to the function, so it needs to be built to handle bytes. Encode the C++ code for the date conversion function in base64. Define a custom field type for HeartIP dates. Custom field types should have a name, the name of the interpreting function, and what the function should return. Next, we have our entry point object, which is where we start parsing each packet. The entry point is a singular object, not multiple objects. Handling of multiple packets within a single stream is done seamlessly in Parsnip. Simply specify where to start parsing. Scopes determine where objects are logged. Each scope corresponds to a specific log file. For instance, data in the general scope will be saved in the general log file unless specified otherwise. To indicate a scope in the intermediate language, the relevant definition files should be placed in a separate directory. This directory should be named the scope name. Add the scope to the scope section of the config file. There are two exceptions to the general log. Objects in Parsnip have features like log independently and log with parent. Log independently means the object is logged in a separate file from its scope. Log with parent means it stays in the same log as the object that points to it, in other words, links to it. This setting is irrelevant for entry point objects since they have no parent. This setting is specifically designed for reusable objects that may be across scopes. If the object is part of a list, each item in the list is logged separately. These items will not be included in the parent log. If unsure, set log independently to false and log with parent to true, except for entry point objects. The general rule is that the scope determines the destination file for the logged data. That concludes this video. For more information, check out the links in the description below. Thanks for watching.